All right, boys and girls, we're going to talk about laws of logarithms today. There's about 6 of them that we got to know. All of them are derived from our rules of exponents. So if you don't know those, go back and watch the other video. For our first one, if we have multiplication for exponents, that actually means that we're adding them. So a to the n plus m. So same idea here. If we're multiplying these, that actually means that we're adding them. So log base a of x plus log base a of y. So we're expanding them. So an example would be like log base 7 of x plus log base 7 of 4 would equal log base 7 of 4x. Okay? Same kind of idea with division. We subtracted them. So a to the n minus m. So here we're going to rewrite this as log base a of x minus log base a of y. So an example for that, if we have log base 2 of x minus log base 2 of 16, this would equal log base 2 of x over 16. And be sure our 2 is kind of below that. You can probably do a better job than I can. Don't make it look, like, there we go. That's a little better. So that's those. We got one more here that's kind of new, and then we got one that's a review. Here we're multiplying, so a to the m times p, so kind of like amp there. For this one, for our log, we're going to move this p out in front, so it's going to be p times log base a of x. So if you have something log base x of, I don't know, 5 squared, we could rewrite this as 2 times log base x of 5. So the biggest idea is that we're moving this exponent out in front. Or if you have an exponent in front, like here, we could rewrite it with moving the 2 there. Change of base we talked about yesterday. This is when we have like some ugly number like log base 82 of 53 or something like that. We can't figure it out, so we rewrite it as log of 53 over log of 82. And you can use natural log too, it doesn't matter as long as you keep it the same. Our next 3 and our last 3 are very important, even though they're very simple. So our first one, all this junk cancels out and it's just x, because we're saying b to what power makes b to the x. Obviously our question mark has to be x. Our second one, once again, all this stuff cancels out and it's just x, kind of the same idea. And our last one, there's one number that we can raise anything to, and it's going to give me 1. It's 0. X to the 0, 5 to the 0, 2 to the 0, they are all equivalent, and they're all 1. All right. Last thing here, or not last thing, the first example is evaluating. Evaluating means give me a number. So addition means multiplication, so log base 6 of 9 times 16, and then minus log base 6 of 4. But we know that minus actually means subtraction, so minus doesn't mean subtraction, but for logs, minus means division, so then I get 144 divided by 4. That's what 9 times 16 is. And then 144 divided by 4 is 36. 6 to what power makes 36? 2. Letter B, 10, we got log of 50 times 2. Well, that gives us 100. And then remember, our base is 10, so I'm going to squeeze it in there. And then using that property, if I go back a second, if we have a number raised to the same number, then everything cancels out. Oops, not what I meant to do. Sorry. So all this junk cancels out, and my answer is just whatever's left over, 100. And last one of these, letter C, we're going to rewrite 16 as 2 to the 4th power, all to the log base 2 of 3. Then I can move this 4. Well, first let's go ahead and multiply. I think that's kind of a duh statement there. And then I can move this 4 out there. So I have 2 to the power of the log base 2 of 3 to the 4th power. All this stuff, just like this one, cancels out. So I got 3 to the 4th, which is 81. Okay, got 4 more, guys. Stay with me. 4 more. Expanding. expresses multiple logs. So I'm going to have various amounts of different logs. So I got log base a of x squared plus, because that's what this means, right? Multiplication. Log base a of y cubed plus log base a of z to the fifth. Now what can I do with all of the exponents? Move them out in front. So I have 2 log base a of x plus 3 log base a of y plus 5 log base a of z. This time we got division, so that means subtraction. I still got a square root of 3, so that means I'm going to be putting those out in front. So I got log base b of x plus log base b of y squared minus log base b of z cubed. And then don't forget, we can move our 2 and our 3 out in front. So my final answer, I can't do anything to the first one, but then everything else, I got the 2 log base by minus 5 log base b of z. That's a 3, not a 5. I can't read my handwriting. Sorry. There we go. 3. Our last two, rewriting as one term. So I'm going to have log base a and then x to the 2/3 divided by, because it's minus, y to the 1/2. And that's as far as we can go. On b, I got log base a of x to the 1/2. Bring the 3 for the y cubed, all over z squared. Okay? Good luck, guys. I'll see you later. Bye-bye.